same as doing?
It should be 52 also, because there are 52 elements in this vector. They're just arranged differently. Instead of A through Z and then A through Z again, this time we're repeating each one twice. And the numbers on the side, these just depend on how big you set your window. But that's saying the first thing is A. The 20th thing is J. The 39th thing is that. So the 40th, 41st, 42nd. Okay. So I'm going to take this whole output here on my line 8, and I'm going to do square brackets after it. What are those for?
Picking a specific element.
Picking a specific element. So if I wanted the 20th thing on here, what would I do?
20.
Just put a 20. And what should it be?
J.
Should be a J. And it is. Well, that's nice. What about 20:25?
22.
And there's our 20th through 25th letter in that repeated sequence. J, K, K, L, L, M. What's the length of that? 6. What's the class of it? Character. All right. So remember, the square brackets let you access specific elements of any object. For our purposes, those will just be vectors and data frames. All right, so that's your character class. There's a lot we can do with it. One thing that we can't do with it is say letters plus 5. Oh, letters plus 5. Non-numeric argument to binary operator. You will see this error. What's it mean?
That you're plusing the character.
There's a character or a factor or something that's not numeric that you're trying to do number math with. How about this? 1 plus 5 should work, and we should get 6. Excellent. Quoted 1 plus 5. Boom, boom, boom. Nope.
Is that, no, that's a character?
It's a character. It's in quotes. So the quoted number 1 is not the number 1. It's just the little ANSI character in quotes that looks like a 1. R no longer knows that it can do math with that because it's in quotes. All right, I'm going to try something here. I'm going to say X is 1 in quotes. Okay. X plus 1 should give us 2 in a sane universe, but it doesn't, because we're talking to the world's stupidest thing, a computer. And it doesn't know that we meant, I really want 1 plus 1.
So X equals equals?
X can never be added because it's in quotes. X is now the number 1 in quotes. It's actually the character 1. Sorry, not the number 1. So anytime I try to do anything with it, like X plus 1 should be 2. But we live in a cruel universe. And the computer says, the letter 1 plus the number 1 can't do it.
So again, how would you actually make X 1? Or is that not possible?
I could do X is 1 like that, and notice the quotes disappear. Now it knows it's a number, and X plus 1 works beautifully, and it gives us 2. Well, I'm going to delete that and rerun this so x is quoted character 1. So that doesn't work. Time for a new function here. R comes with a bunch of stuff that's as dot whatever. And so we can try to convert things from one class into another. As numeric x. Lovely. What about this? As numeric x plus 1.
So that should work because that as numeric x is now turned into an integer form.
And it gives us 2.
So R can read strings or character strings sometimes.
Sometimes. If it's a number, it knows how to turn those into an actual numeric. Okay. What about this? As character 1, 2, 3. Plus 1. Failure. I would hope that this would be 124, but it can't do it because before it adds, it's converting this to a character, putting in quotes, so now it no longer knows how to do math with that. This is going to happen to you all the time. You're going to read in a data set, and there's a column that should be numbers, and they're all going to be in quotes all the way down. Let me show you why. I can concatenate the numbers 1 through 10 together, and then go ahead and tag on the word 1 in quotes. What happened?
Just added 1.
And
It converted everything to a character.
every single one of those things got turned into characters. A vector, this is important, can only be one type, all the way down. Can't mix numbers and letters. So if there's a single item in a vector that's character, everything in there becomes a character. The reason R does that is because it doesn't know that you meant the number 1 here. It just sees character and says, I'm going to keep that as it is. Everything has to be the same type. So I've got the numbers 1 through 10. The easiest way for me to make everything the same type is to put quotes around everything, call it a character. That's the least common denominator there, so that's what it does.
So if you have some entry in the table that's like NA or some other thing, it's just going to be real.
I've never encountered a data set in the wild that was like already cleaned and nice. There's always some column in there that should be numbers, and some idiot has typed the number 1 as O-N-E, or they've hit 1 and then the space bar. 1 with a space after it is 1 with a space after it. That's not a number. And so R will interpret it as everything's a character. So how can we get this back into numeric form? I'm going to save that as Y, just so we can have it easier to call up. You can see it's a character vector of length 11. How do I make it numeric? As numeric. As dot numeric Y. And what's going to happen when I do that? What's your best guess?
I don't think it's going to know what to do with the word 1.
I think it's going to know what to do with 1, 2, 3, 4, 5, but it gets to the word 1. And it did just fine up until that one. And then it gave us NA and said, warning, NA is introduced by coercion. So in other words, there was something in there that it didn't know how to unambiguously convert to a number, and so it just said NA. Now remember how true in all caps is a special word in R, and false is a special word? NA in all caps is a special word also. And what's it mean? Missing data. Refers to missing data. So if I type NA, it changes colors. Just like true and false. So that's all well and good. You can coerce a character to numeric, but it only works when it works.
I have a question.
Mhm.
Dumb, but it's very crazy. When do I know when to put spaces in my code?
Spaces don't matter in R. So whenever you want to make it look nice. So I could say y is 1, and that works just fine. I could also say y is 1, and that works just fine. So spaces don't matter. As numeric, y. All right. What's going to happen with as numeric letters? All of them are going to be an A. It did its job. It worked perfectly. It's not giving me an error message. It's like, all right, you want this? You got it. They're all an A. Okay.
Yeah.
Oh, yeah.
So like when you're looking for a file and the file has a number in it, would you put quotations around the number? If like the file has a number?
No, you don't have to, because the whole file will be quoted.
Well, if like you're looking for it, like I need all the files that start with 1.
Oh, yeah, that's the character 1. Because the file name, unless it's just the number 1, it's going to be a character no matter what. So 1.txt, that's a character altogether. All right, so we got the number 10. Class of 10 is numeric. Class of 10 capital L, integer. Almost never will you actually have to worry about this. Back in the early days of computing, when space was like a real premium and everything had to fit in like 256 kilobytes, integers are stored in less space than floating point decimal numbers, and so there's a separate class for them. If you really want to force something to be an integer, put a number and then a capital L after it. I will never do this again in class. But sometimes you will see that in help files. So question mark head. Look at that. Head, x, n equals 6L. That just means 6. Just wanted to make you aware of that. All right, that's the last time you'll see me do an integer. The length of 10 is what? One. There's only one number there, one element. And we could do the rep, so we could, just like with characters, we can repeat the number 10 30 times. You get the number 10 30 times there. We could repeat 10 through 15 30 times. Or we could do it each equals 30 times, where there's 30 10s, then 30 11s, and, or wait, 10, 11, 12, each equals 30. There we go. I forgot to hit Control Enter. Repeats each of those items 10, 11, 12, 13, 14, 15, 30 times in a row. So repeat works there, but we also get seek for making sequences of numbers. So what's that one do? There's the output.
Is it making sure there's like an equal distance between three numbers?
Mhm.
1 to 10?
If I did seek from 0 to 10, length out 3, it should be what?
0, 5, 10.
0, 5, 10. Length out 30. Right. So we can make sequences of numbers this way. Be aware of that. That's in your practice problems for this week. But just to show you that the numeric class has a bunch of different things that you can do with it than the character class. And character class has a bunch of special things you can do with it that don't apply to numbers. And for now, last but definitely most annoying is factor. This is special in R, different kind of special than in Python or Perl. We can make a factor by just using the factor function. So we can take letters and make it into a special type of class called factor, and you can see it pops up here. It says factor with 26 levels. What's a factor?
It's kind of like a grouping. It's kind of like a string, but it's like also a grouping.
It's a character, but with a special added, here are the known levels, and everything must be one of those. You can't be outside of one of those levels. Class of x is a factor. The length of x is 26, just like it was before. And the levels of x, that's only something you can do with a factor, is levels. Here are all the different possible discrete values that this can be.
So if we try to concatenate x now, it would not like that.
Let's try this. Z is repeat x each equals 50. What's the length of z going to be? I don't know, 26 times 50. 1,300. X is just the letter A through Z, where each of those is a possible factor level. Z is the letters A through Z, each letter repeated 50 times. And what are the possible factor levels for that? The same, A through Z. So when I say levels X, I get A through Z. Levels Z, A through Z. And if I just type Z and hit Control Enter, there were 1,300. By default, it's only showing me the first 1,000. And it says omitted 300 entries. But you can see this is what our thing looks like, our vector. When you see this at the bottom, you're dealing with a factor. There is no warning that's going to come up and say, hey, idiot, you're working with a factor, not a character. That's your warning. If you see the word, if you just like look at your vector, Z, and you see levels, you're dealing with a factor. Those behave differently and more annoyingly than character vectors. We will mostly try to avoid them. There are times when they're very useful, and that's why they're here, but be aware. This is another problem that comes up. Most common problem is file not found because you messed up your file path. Second most common problem is you've got the wrong class to do that type of operation. Right? Non-numeric provided to binary operation. So this is one of those. Just write that down. If you see levels at the end, you've got yourself a factor. What that means is if I tried to add a new item to this, so let's say Z square brackets 1300, what's that going to give me? Should be Z, or last letter. And sure enough, it says levels. The 1300th thing was a Z, but since it's a factor, even though it's now length 1, it's saying it can be one of these, and it cannot be anything else. If you try to get it to be anything else, what do you think happens? NA. So I can try that. My little C command is to combine or concatenate. So I can combine Z 1300 and a capital letter A. Well, that's real nice.
Well, turn that into 26, the Z into 26,
Mm-hmm.
and it turned it into a character.
Mm-hmm.
And there's
Oh
no-
dear, isn't this confusing and terrible? What happened?
It coerced everything to be string.
Our 1300th thing is Z. Why did it turn it into 26?
Because it can only be between A and B in those levels. So the 26.
It was the 26th type of thing. These are stored as integers in the background, the levels of your factor. That gets super confusing and horrible, I know.
Like a Frankenstein of integers and characters.
It's awful. But what's happened here is that it doesn't actually store that as Z. It stores it as, oh, you're the 26th level. That saves a lot of space when you're working with huge data, and that's great. Yeah.
Does it tell me 26 because, so, does it tell me 26 because 1300 is greater than 26, or
Because the 1300th element of Z was Z. So it looks it up here and says, ah, what you actually had is not the letter Z, but the 26th type of item that you can be. So factors are for discrete variables, right? Like eye color. You cannot have neon green eyes as a human. It's not one of the possible levels. We're not going to spend a ton of time intentionally working with factors for a while. We will when we get a bit more advanced. I want you to be aware of them because they will come up. All right, so what if I did this? As character Z, what do you think is going to happen? It can handle it. What about as numeric Z?
But turn it 1 to 26.
1 through 26. Not a bunch of NAs because it's a factor. Now, as numeric Z in quotes, a single NA, yeah. So, factor class has a bunch of special rules. worry about memorizing them now. You can learn them yourself by playing around with the as numeric, as logical, all that good stuff. Those as dot, look at all the possibilities for coercing one thing into another. When in doubt, just go down the list and see if you can find the thing you need. Okay. Yes?
What about like special characters? Do they have their own like class or just a character?
Yes and no. If you put them in quotes, they're treated as just normal characters, usually.
Would like an exclamation point be like 27?
No, so as numeric, you're talking about special characters like
That
asterisk.
exclamation point,
That's going to be an NA.
There's probably a way to get to like the ASCII code for it.
Yeah, there is. Exclamation point is a special character outside of quotes. Inside of quotes, it just is a thing that looks like an exclamation with its own ASCII code. But exclamation false is true. It means not. Yeah, it's the inverter. 1 exclamation equals 5. What's that going to give me?
not equal to 5.
False. Wait, true, yeah, sorry. 1 is not equal to 5. Correct. 1 is equal to 5. False. Okay. So if you want to say not equal to, it's exclamation equal. All right. Now everybody should have a data frame built in called MT cars. What do you think this thing's about?
The cars that are low on fuel, empty cars.
It's miles per gallon, right? So it's one of these built-in data sets for teaching R. Okay. How do I just get the miles per gallon column? If you're not immediately answering, that means you didn't spend 6 hours a week practicing, and I'm ashamed of you. $sign. $sign. I'm betting miles per gallon is MPG. Control Enter, there we go. So there's the miles per gallon. That's a what type of object?
Vector,
Numeric vector of length. I'm seeing 32. If I want to know the dimensions of this whole data set, it's dim MT cars. $32.11. Number of rows, number of columns. Always, always, always in that order. Rows, then columns. Okay, so if I want, here's good old MT cars again. I just want the first row and the first column. What value is that going to be? 21. Row 1, column 1, that's the number 21. So using square brackets, what can I do? MT cars, square brackets. 1, comma 1. Rows, columns. That's how it works. And look, it's the number 21. Excellent. So it's rows, comma, columns inside the square brackets. Why do we have to put two numbers? I mean, when we did this before, we just said like letters 5 is E, right?
This is two-dimensional.
It's two-dimensional. It's not a vector, it's a data frame. It's a bunch of vectors stuck together. So we have to tell it what rows we want and what columns we want. All right, what if I did empty cars 1, comma, nothing? That's a shortcut for I don't care what columns, just give them all to me. But I only want row 1. All right, now your turn. I want to see rows 1 through 3, just columns 1 through 3. You told it, I mean, does it look like you're getting just rows 1 through 3?
Did you say rows 1 through 3 and
Yeah.
columns 1 through 3?
Mm-hmm. Yep. And you told it just column 1, but I want columns 1 through 3 also. Yep. Perfect. Excellent. Excellent. Yep, yep. Okay. Give me 1 through 3 for rows and 1 through 3 for columns. There we go. All right, tricky one. Just 1 and 3, not 1 through 3. And you don't actually know how to do this. I'm going to show you. If I want to stick together two numbers that aren't next to each other, I mean, it's really easy to do like 1 through 10 and get all those integers. But what if I just want 1, 3, 5? I have to actually stick them together, 1, 3, 5, with my combined function. Just lowercase c, anything between commas, it'll stick them together. So knowing that, give me rows 1 and 3, columns 1 and 3. Does this look about like what you got? All right. Here's the real comma that matters, separating my rows and my columns. I'm giving it a vector of length 2 for my rows, 1 and 3. And then for my columns, I'm giving it a vector of length 2, 1 and 3. Yeah, Mark.
I tried to do first C parentheses, but it didn't work. Or it's just
You did 2 parentheses?
so that I didn't have to put 2 C's. I put 1 C.
Oh, you have to do it on each side of that comma. because it's saying, hey, which rows do you want? Well, I'm going to give you a vector of the row numbers I want. Then comma, which columns do you want? Here's a vector of the columns I want. And so if I wanted to add in column 5 for those, I'd do that. I know it's kind of ugly. It's a bit confusing. There's a lot of commas that have to be in the right spots. But if you spend enough time working with vectors, this looks perfectly normal. We've got just 2 vectors here. C makes a vector. There's one of them. If I hit Control Enter, what's going to happen with just that highlighted? Just the numbers 1 and 3, which is a numeric vector of length 2. If I highlight this and hit Control Enter, it's 1, 3, 5, a numeric vector of length 5 or 3. So I say empty cars square brackets. This is what it's reading. Here's the rows I want. Here's the columns. All right, so I'm going to say head empty cars. Just get a quick look again. Let's get a bit crazy here. I'd like to subset this. So I'm just looking at the rows where miles per gallon is greater than 21. How could I do that? And there are like 65 right ways to do this.
I would figure out how to get the, I'd first figure out how to filter out ones that weren't 21, and then I try to put that back into.
How do we ask a true-false question about greater than 21? Okay, so I could say, all right, well, write this out for me verbally. What would I type to ask, is the MPG column greater than 21?
Empty cars, $sign.
Empty cars, $sign, MPG. And what? Greater than 21. And what's that spit out? Bunch of true false. How many true falses? 32. Because that's how many times it asks the question, because that's how many rows, how many elements were in MPG there. Cool. Well, we're basically there. This could be a true-false list of which rows to keep. Do I keep these rows? No. That one? Yes. So how about this? If that little expression right there gives me 32 true-falses, could I stick that inside of square brackets? Let's see. Empty cars, square bracket. For my rows, copy that, paste it in, and for my columns, I don't care, all of them.
So, the row column argument, they can either take a vector of numbers, or they can take
A vector of true false that's the same length as the number of rows. It can take a lot of other stuff too, but those are the two we're dealing with right now. Now I need you to understand what happened here at a cellular level before we move on. Not like a, oh, I guess if I type this, that works, or why is the comma there? If you're asking that question, you do not understand this at a cellular level. So, how can I explain it better for any of those remaining questions? I know the syntax is a bit confusing, but we broke it down. You know what the $ does for a data frame. You know what greater than means, and then you know what the number 21 is. Okay? Altogether, that gave us a bunch of true falses. Instead of barking it up to our screen uselessly, we're going to use that and say those are the rows we want. And for the columns, all of them.
And then it's only going to output a row that has a true in it, not
Correct. It'll output the rows that had true, or that matched up with that same element of the weird vector that we gave it. So if I wrapped this whole thing in class, it's going to say logical, because the output of that was a bunch of true false. If I say length of that, it's 32, because we asked that true false question 32 times. So that is a vector, this right here that I've highlighted. It's just a vector of true false. Question, Lauren?
If we put after the 21 comma 1, would that give us just MPG or would
Yeah. That's just the MPG column, the first column.
But isn't the first column the name of the class?
No, good point. That's actually the row names. You see it doesn't actually have anything above it.
Okay. So is that 0 or that's nothing?
Don't worry about it right now. That's just the name of the row. We can get those later if we want. So if I say row names of MT cars, there they are. I could add a new actual column of the row names to the data set. How would I do that?
empty card, $, name it whatever you want.
Car name or something.
And then could you just set it equal to the row names?
Sure could, and I did. So now MT cars has a new column on the block. They always put them to the right by default. There it is, name. So you can see they're over here. That's just the row name. If we actually want that data being part of our data set, we would set a new column to be equal to the row names of that data set. I'll put this on the same line so it looks normal.
So put a new column as alt minus.
And alt minus is the assignment operator. Whatever would have been the output of the thing on the right becomes the thing on the left. Now, there's plenty of ways to get an error there. MT cars, new column is 1 through 10. That's not going to work. How come?
There's 32 rows.
Yeah, there's 32 rows. And sure enough, it's a pretty good error message. Replacement has 10 rows, data has 32. You can't do that. 1 through 32. That works. And so now I've got a really stupid new column called new column. That's just the numbers 1 through 32. You can keep stacking new vectors onto this data frame all you want. Okay. As long as they're all the same length.
I have a question.
Yes.
So you have two tables, can you do, like for example, empty cars, new column is equal to this column of this table?
Mm-hmm. Sure can. It's very nice. Yep. You could have two separate files on your computer, read them both in, and merge them together into one nice data frame. Yep.
So if empty cars, dollar signs, whatever, adds the new column, how do we add a new row?
A new row. MT, let's see here. Dimensions of MT cars, 32 and 13. So each row has to have 13 items in it, right? MT cars, all the columns, but wait, that's column 30, row 33, all the columns. It says a bunch of NAs. There is no row 33, but we could just send in something as character 1 through 13. So that really does access that part. That's row 33, which didn't previously exist, and now it does. And it's just the character number of 1 through 13, because I didn't want to sit and try to come up with stuff for that. So that assignment arrow will let you do anything you want. Another beautiful thing about it is that it'll, well, beautiful is probably the wrong word. Terrifying thing about it is that it would happily overwrite row 1. I'm doing it. There, I've just overwritten row 1 with the numbers 1 through 13. Notice that it didn't ask me permission or say, are you sure? It just did it. Okay. Yeah, sure, I'll do rows 1 through 32. I'll override it with all that stuff. And now empty cars is just trash. I've killed it. I'll reload it here. Now we're back. Now, for the most part, since we're not writing out to files yet, anything that you do inside of R, if you destroy your data set, it doesn't matter, because that's not your actual data set. Your data set lives on a file somewhere else on your computer. You just read it in and memorized it briefly, and you can do anything you want, destroy it. Okay, just read it in again, and you're good to go. All right. Now, I do want to talk about the old for loops. Who got them figured out? What's the idea behind a for loop?
To go through a bunch of tables and get a certain row.
I don't like the word tables there.
Files.
No?
It's just doing something over and over again.
It's doing something over and over again.
For a for loop, you're doing it over a, I don't know what you call it.
The word tables mess me up, but values I like. All right, so let's look at this. 1 through 10, sure. So here are some potential values that any variable could be. So we could have x equal 1, or x could equal 2, or 3, or 4, or 5, or 6, 7. So let's say that we wanted to add each of these numbers to the number 5. Well, in R, it's really simple. I just say 1 through 10 plus 5. There they are. In other programming languages, they're not vectorized, so they can't do that automatically. You would do a for loop. So it works like this. For some variable name, whatever you want, for your mom, in, and then a list of values that you want your mom to equal. So I could say 1 through 10. Or I could say letters. Or I could say MT cars $, MPG. Anything you want. We're just giving it a list of values that we want that variable to be equal to. And then we're going to do a loop. And the first time through the loop, your mom will equal the first thing in that list. And you can do some stuff with that. And then it goes back. The second time through the loop, what's your mom going to equal? The second thing. In this case, the number 2. Okay. So then in the curly brackets, whoops, outside of that, here's where we do whatever stuff we wanted to do with that variable. So your mom plus 5. It did it, but it didn't show us anything. Print. We didn't tell it what to do with that. Okay, so for your mom, in the soon-to-be values of 1 through 10, first time through I want your mom to be 1, second time 2, 3, 4. What I want you to do with that information is I want you to print your mom plus 5. And there we go. Let's try it with a character class for your dad in letters. What could we do with those letters A through Z? Print, paste, your dad equals, and then your dad. What's that going to do? It's going to type your dad equals and then the current value of your dad. First time through it should be A. So there you go. Not too shabby.
Could you have said print your dad equals brackets? Your dad?
No, not brackets. Because what's happening is once we enter the loop, this variable name becomes the first value of this list of options. So the letter A. And so now anytime inside of these brackets that we say your dad, that's going to be A. And so what we're really doing is saying your dad equals, and then a space, and then A. Then the next time through, it takes the second value. Third time through, third value. So if we wanted to read through a bunch of files, I don't know, for like some sort of second assignment in a course or something, list files from data, pattern equals .csv, full names, yes please. There's all the CSV files. I can save that list of stuff as my files. Now that I've got it as a list, or actually a character vector, to be precise, I could write a loop that does something to each of those files. Like what?
Like read the first line.
Like read the first line. I could say for, and I'll just say I in my files. What should I do? I should print the read lines of I n equals 1. Somebody describe to me what's going to happen here. And do it like I'm 3 years old. Why did I pick I as my variable name? Just because. It's also very common. If you look at help files and stuff, you'll see that. I, short for iteration. What is my files?
All the CSV files.
Yeah, it's a character vector of length 33 with directions to get to those files that actually exist on my computer. So the first time through this loop, what is I going to equal?
The last call.
First time through. I will be equal to data 1620 scores.csv. Second time through the loop, it'll equal that. The 13th time through the loop, it'll equal this one. Okay, so I'm going to read lines of I, and just the first line, please, and then I'm going to print it. And it worked. There's the first line of every single CSV file. Following okay? This idea of a for loop is something that's going to come up over and over and over again in any computer work that you do. Because it's really powerful, it's actually pretty nice and tidy to write it. Once you understand that the value of that variable, I, is just going to change. All you need to do is feed it the values you want and tell it to do something to each of those. Yes?
I was just going to ask, so while doing the assignment yesterday, I was looking up that a lot of people were using while loops. Are we going to have to use those in this class?
No.
No? Just go for 4?
Mm-hmm. A while loop does a true-false test to decide whether or not to keep going. So you could say, like, while x is less than 10, keep doing this, and then add 1 to x. We'll skip it.
It's easy to get accidentally into loops.
Yeah.
Yes.
I'm getting an error and I don't understand it.
What's the error say?
It just says unexpected curly bracket in
You need an extra
curly
parenthesis.
Well,
bracket.
there you go.
But I can't find it. Another curly bracket that which opens this and then close it there.
For I in my files, curly brackets, looks good. Oh, so it doesn't see that as a curly bracket because you forgot to close another parentheses there. There you go. See how it kind of highlights the one that you're on? There you go.
I also have what the unused argument equals 1.
Because you said read line instead of read capital L-I-N-E-S.
Usually when it does that, I'll just click on the line that says escape.
Is it escapes in this too?
I knew this happened, but I don't remember.
That happens all the time.
If you do N1 column 5 through, you read the first 3 rows.
If I wanted the first 3 rows, I would say n equals 3. The number of lines to read is 3. The only reason I would know that is because I looked up the help file for the read lines function. Get used to that. You're going to spend plenty of time reading the help files. So here would be the first 3 lines of every file. All right, I need to run the whole thing. There we go. And if I actually wanted to read in the entire file as if it was a data frame, what could I do? Instead of read lines, read.csv, and I would get rid of that n equals 3. And I would say read.csv. Whoa, there it is. Every single one of them, it's still printing them all out. Okay, got them. So it just gave me the contents as data frames of 33 files. Can you think of a time when you might have, like, I don't know, 1,000 files that are all the same basically, but they're stored separately? I can, having done this for a long time. Happens all the time. Lots of software will put out a new CSV file for every day. And so if you want to look at some pattern over time, you got to read in 20,000 CSV files and get them all stuck together. For loop. It'll happen for you in seconds. Right? Just read them all in. There you go. As we get more into this, we'll start seeing another type of object called a list, which is different than a vector. Every item in a list can be anything. A vector, everything in a character vector has to be a character. A list, one of the items in there could be an entire data frame. And the next item could be a statistical model describing that data frame. So we could stick together all of these in a single list and have 1,000 data frames in a single list. But not yet. Okay. In our for week 3, where we are now, I've got all these little practice brain teasers for you. Right, so there's loops in R. Come on. Right, these are brain teasers and exercises. I want you to go through them. I did not put these here for my benefit. I already know this stuff. Okay. There's plenty of resources here for you getting used to, like, oh, all the operators I can use. Less than, greater than or equal to, not equal to, not x, x or y, x and y. So look through them, get a feel for all these sorts of things, because we're going to be running with them. If you know how to ask a true-false question, you can do some pretty complex subsetting. Right? Okay. Next class period, we're going to start on assignment 3, where we just basically download an R script, and we're going to work through this together. It'll review a lot of the stuff we've already done today, but then get into, I want you actually using this. Okay, and that'll be your homework, is to finish this R script, these 6 steps. Okay. Anything else I can help you with? Well, we still have a few minutes, just in what we've covered today.
Just to clarify, on read lines, the n equals whatever value, is that saying the specific line or just the number of lines to read?
Number of lines to read.
Okay.
Yeah. So I don't think you give it n equals concatenate 357. But if you wanted to, like maybe we just wanted line 3. If we read the first, wait, that's read CSV. Read lines, I, n equals 3. When we read those in, it's giving us the first 3 things from each file. We could just say, hey, subset to that third one. Oh. No, it didn't like that.
Oh, it's in The print.
Oh, it's in, yeah. Print that. There. There's the third line from every file. So I'm going to print the first 3 lines of whatever value I is, and then just give you the third one, and then I'm going to print that. So I guess I could trick it this way, have it read all the lines, and then just give me rows 5 and 6. Notice that they're numbered 1 and 2 for each of these, but whatever, not my problem. That's the first thing and the second thing, which is row 5 and row 6.
So the NAs there, there probably was a blank.
Oh, look at that. I mean, this didn't have, yeah, some of them didn't have like 5 and 6 lines in them. So if a file only had 3 lines, it's going to give you NA. All right, so as you're practicing, which you will do for 6 hours this week, 6 hours, it's a 3 credit hour class, which means 6 hours of outside time. Your homework's not going to take you 6 hours, but you're learning a new language, so you will spend 6 hours working on this. Play with empty cars. Can you subset it over and over until you get comfortable here? Maybe put together a couple chains of true-false questions. Can you get just the cars that have miles per gallon over 23 and are also automatic transmission? I know you don't care about that answer, but that's how you practice this stuff, right? Just come up with a bunch of bullshit questions, see if you can subset it to get there. All right. For 6 hours, actually, like 3 of those hours are going to be going through all the resources on the website, videos and stuff for you. If you spend an hour subsetting MT cars, you're going to be good to go. If you spend 15 minutes doing it and say, I got this, I'm going to assume you spent an hour on it and conduct a class as if you did, and you're going to feel like a real idiot. You start moving faster in here. Okay. Am I scaring you enough? All right. Because next week we start plotting. And that means that you already know how to subset real well, or else your plots are going to look like shit. Which is fine for assignment 5, where we have the ugly plot contest. Okay? But for the rest of your time, you want your plots to look nice and be informative. All right. Another thing I want you thinking about assignment 4 is coming up. It's not a coding assignment. It's you coming up with your idea for a final project that you want to work on and pitching it to me. So you can think about that in your free time. What data set do you want to look at? What new type of question do you want to learn how to answer? What